Okay, now we're going to go into a couple more trig identity problems. So we're going to start off with one that's fairly simple, and we'll go on to discuss problems that are a bit on the hard side. Okay, so let's start off with this one. Show that sine of x times cotangent of x over secant x equals cosine squared x. So first step, you always have to put everything into terms of sine or cosine. So here I'm seeing cotangent x and secant x that aren't in terms of sine or cosine. So let's do that. Sine of x times sine of x over cosine, or cotangent, whoopsie daisies. I thought this said tangent. Okay, sine of x times cosine of x over sine of x over secant x is the same thing as 1 over cosine x. So, in the numerator, these two signs cancel, so we get cosine x in the top, and then we end up getting 1 over cosine x in the denominator. Now, when you're dividing by a fraction, you multiply by its reciprocal. So cosine x times cosine x equals cosine x squared. See? It's as simple as that. Okay, let's try another trig identity problem. Here we're asked to show that cotangent squared x minus cosecant squared x over secant x equals negative cosine x. So, right off the bat, I'm noticing cotangent squared x minus cosecant squared x, and that reminds me of a Pythagorean property. So, let's start there. So the only Pythagorean property I have memorized right now is sine squared x plus cosine squared x equals 1. And this really should be the only one that you memorize, because you can find the other two by dividing by either sine squared x or cosine squared x. So, to get cotangent squared x, we're going to need to divide cosine squared x by sine squared x, because we remember that tangent equals sine over cosine, and cotangent equals cosine over sine. So we're going to divide everything by sine squared x, sine squared x, sine squared x. We end up getting 1 plus cotangent squared x equals cosecant squared x. Okay? So now we're going to move these pieces around a little bit so that it looks more like this. Okay? So, if we subtract cosecant squared x, both sides, we get 0. And then we subtract 1, so we get cotangent squared x minus cosecant squared x equals negative 1. Now notice, this matches up with this, so we can just plug in negative 1 for the numerator here, right? And then we have negative 1 over secant x. Now, 1 over secant x should equal cosine x, right? But here we have this negative. So once we put in that negative, this becomes negative 2, and we'll see that this matches up with what we were supposed to show that it could become. So we're asked to show that sine of theta over sine of theta plus cosine of theta yields tangent of theta over 1 plus tangent theta. So, before in many situations, the stuff that we were supposed to tamper with to make it look like this has been on this side. But this is one of those rare cases, though, I mean, it's not very rare. It happens sometimes. But here, we're going to we're going to tinker with this side to get here. And you know how I know that? Is how I see here, everything is in terms of sine and cosine. Here, everything is in terms of tangent and 1. So we can tell that this is the side that would be best to. I'm not saying that you couldn't tinker with this side, but I just feel it would be best to do this side, right? Okay, so let's start off the problem. So, write everything in terms of sine or cosine. So here we have tangent of theta. We're going to rewrite that as sine of theta over cosine of theta over 1 plus sine of theta over cosine of theta, right? That's the same thing. We've just rewritten it using some of the quotient properties. Okay? So now, I'm not really digging this whole factor, that's what it's called, brain fart, this whole factor in the numerator. So what we're going to do is we're going to multiply everything here times cosine of theta, right? So this effectively, I cannot speak today, cannot talk, this effectively will get rid of this. So at the top we only have sine of theta, and at the bottom we have to multiply everything by cosine of theta. So we're going to get cosine of theta, 1 times that is just cosine of theta. And then here, this is going to cancel out this bottom cosine of theta, so we're going to get equals sine of theta. And here, if you notice, this is exactly that. I mean, the denominator is rewritten differently, but it's the same thing. Like, you can write it however you want. Like, if you were to say 3 plus 2 equals 5, you could also say that 2 plus 3 equals 5. The order doesn't really matter. So here, we solved it. Okay, now let's try a harder trig identity problem. So here we have show that secant of theta plus cosecant of theta over 1 plus tangent of theta yields cosecant of theta. Now this looks a little bit overwhelming, but if you just take it real nice and slow, it'll be okay. Okay, so the first thing I'm not really liking about this problem is the fact that everything is in terms of secant, cosecant, and tangent. We want to change that. We want everything in terms of sine and cosine. So we're going to change everything. Secant, that's the same thing as 1 over cosine theta. Cosecant, 1 over sine of theta. And then we have tangent on the bottom. That's the same thing as sine of theta over cosine of theta. Now, the next thing I don't really like about this situation is the fact that we're adding these two things in the numerator, but they don't have the same denominator. So we're going to change that. We're going to multiply this side by sine of theta, both the denominator and the numerator. Remember, because you can't just multiply the denominator by this, you have to multiply the numerator by it also. And this one by cosine of theta over cosine of theta to get this a similar denominator, so you can add them together. So we end up getting sine of theta plus cosine of theta over cosine theta times sine of theta over 1 plus sine of theta over cosine of theta. Now, the next thing I don't like about this situation is that we have this fraction in the numerator. I don't like that. I don't like that one bit. So, with trig identities, a lot of times it's kind of like, see what works, see what doesn't work. But with me, it's just kind of like, what seems out of the ordinary that we have to change in order for it to equal cosecant of theta, right? Okay, so what we're going to do here is we're going to multiply both the top, this here, and the bottom by cosine theta times sine theta to get rid of this in the top. Okay, so multiply times cosine theta, sine theta, everything. So the top numerator is going to be sine theta plus cosine theta over, and then the bottom. Okay, so the bottom. Here we have 1. 1 times cosine theta, sine theta is just going to be cosine theta times sine theta. And then this here, sine theta over cosine theta, when we multiply it out, cosine theta, these two cosines are going to cancel out, so we're going to end up getting sine squared theta. So plus sine squared theta. Erase this. Kind of running out of room here. Okay, now the next thing that I notice about this is that we have two things that have sine in them. So what I want to do is I want to factor out a sine out of one of these things, right? So the top, the numerator, is going to stay the same. But this bottom, since this is being multiplied, we can factor out a sine theta, and we end up getting times cosine theta, and then plus sine theta. So you can see that if you were to distribute this sine theta, into these parts, you would get this. So it's the same thing. We're just kind of factoring stuff out to make it look nicer. And now you notice that cosine theta plus sine theta appear in both the denominator and the numerator. So we should be able to cancel them out. So we end up getting 1 over sine of theta. And looky here, 1 over sine of theta can be written as cosecant of theta. This is what we were originally trying to get. So here, we solved the problem.